Use standard enthalpies of formation from the equation sheets or the back of your book to calculate delta H naught reaction for this reaction. Then draw a reaction energy diagram for each reaction using reaction progress on the x-axis and potential energy on the y-axis. Label delta H reaction, reactants, and products on each diagram. And I guess I cut and paste this from a former written homework problem where I had multiple reactions to do. We only have one reaction to do, and it mentions the equation sheets for standard enthalpies of formation. The equation sheet's going to look like this. This is my Chem 1010 version. And you're going to see in tiny script here, this says delta HF naught, which is the change in the heat of formation under standard conditions. And let's see, oxygen's on here, I know. So oxygen right here is 0 kilojoules per mole. Let's see, H2S. Let's see if that's on here. Yes, H2S gas minus 20.6. So in this, you're going to look up all of the delta HF values to make and calculate a delta H reaction. Here's what this looks like for me. I'm going to write the reaction itself. And then I'm going to make a little table. And the little table is going to be each of the values for delta H of formation, delta HF, and the units will be kilojoules per mole. When I look them up on this sheet like I just did, I know that oxygen is 0. And I know that, let's see, H2S gas, make sure you get the phase correct, is minus 20.6. H2O gas is minus 241.8. And SO2 gas is minus 296.8. Now, to calculate delta H reaction, it's going to be products times coefficients minus reactants times coefficients. That's the general formula. And we can think of this just like the previous problems we've done for coffee cup calorimetry, in which it's the final state, which is the products, minus the initial state, which are the reactants. Now, here's what it looks like in practice. I'm going to start with our products. It's going to be 2 times negative 241.8. That's kilojoules per mole, plus 2 times minus 296.8 kilojoules per mole. I'm stacking up my units to save space again, minus the quantity of all the reactants, which is going to be 2, minus 20.6, and plus 3 times 0, and I guess I'll write that in, plus 3 times 0 kilojoules per mole, which doesn't change the math at all, but for a sense of completeness, we'll put it in. Now all that's left over is to do the math. It's going to be 2 times minus 241.8 plus, let's see here, there we go, plus 2 times 296.8 minus, and I'll do an interim here. That should be about minus 1077, because this is 2 times 300 and 2 times 240. Yeah, that sounds good. Now on the product side, I've got two minuses, so I'm going to change them into two pluses to cancel them out, which means that I'm now going to be adding 2 times 20.6, so plus 2 times 20.6, and that gives me minus 1036. And my units, kilojoules per mole. And this is a lovely way to do and find delta H reactions. And it's pretty common, especially for engineers, but also for other scientists. Any questions about this?